All right, I think we have enough people. Let's start. Good morning, good afternoon, and good evening, everyone. Welcome to the second ES webinar this year featuring ESP conference hosts. The conference will be held in Darwin, Australia from 23 to 27 of June, and with a topic focusing on nature-based solution inspired from Down Under. And today we have the host for the session T4 in the ESP conference, with a topic from outer space to local ecoservice mapping, harnessing state-of-the-art data, method, and tools for various spatial and temporal scale. We have two speakers from the session today. We have Professor Dr. Benjamin and Professor Dr. Solens, and accompany them by two ES moderator, Zhao and Rahul. So Rahul is currently a doctoral candidate at Forest Research Institute in India, and his research focus on ecosystem service provided in the Himalaya regions. And Joao is a PhD candidate in the University of Humboldt in Berlin, and his research focus on urban ecosystem services. So now I will pass the floor for Rahul and Joao for the next part, and we hope that you will have a good time.
Floor for the
Okay. Hello, everyone. Today we are delighted to have you join us today for this insightful pre-event webinar showcasing cutting-edge advancements and practical applications of mapping ecosystem services. So today we have the pleasure of welcoming Dr. Benjamin Burkhard, Professor and Executive Director of the Institute of Physical Geography and Landscape Ecology at Leibniz University, Hanover. Professor Burkhard is a leading expert in landscape ecology, ecosystem services mapping, and human-environmental relations. And with over 20 years of experience in the field of ecosystem services, he has several he served as a co-chair of the Ecosystem Services Partnership and vice president of the International Association of Landscape Ecology. And given the importance of mapping ecosystem services in today's landscape, we are fortunate to have Dr. Burkhard share their expertise with us. And without further ado, I'll hand it over to Dr. Burkhard to present her experience and to share his experience with us and present his presentation. To Dr. Burkhard.
Yes, thank you very much to invite me to this very interesting webinar. Nice to see so many of you. I think now it's 66, which is very nice to see the YES community around here, which I always appreciated a lot. It's a very nice initiative of the ESP. But I guess you don't want to hear me talking about this stuff, more about ecosystem services mapping. So I will start straight away with my presentation. I will start a little bit with the basics of ecosystem services mapping, as 50% of you indicated that you are quite familiar with it, so I can keep this very short. Then I will talk a little bit about applications and policy and decision making, present our new project, or not so new anymore, but the SELINA project, and some practical applications of ecosystem service maps so that we know why we are doing this. And then in the second block, Solen le Clech will present some newest developments of ecosystem service mapping, new techniques, which will also be the main part of our session at the Darwin conference in June. And in the end, we will present a little bit, or she will present a little bit about this thematic working group on mapping ecosystem services that we are doing. But let's start with ecosystem services mapping. I guess, of course, you all know what ecosystem services are. But the key thing from mapping, of course, is that all the services are actually supplied by ecosystems. So they can be either individual ecosystem types like a forest or a city or a river, or they, of course, supply the services in combination. Think about water-related services. So you always usually look at the catchment for water regulating services. The key for our mapping is that all ecosystem services, their supply, their use, the demand for services, they all are spatial phenomena. So they all take place in space, which is very important to consider. That's also why we need actually maps of ecosystem services. So there's no single service that doesn't relate to any place or location or space for its use and its supply. So this is why we want to map them, supply and use. see what are relevant areas, where hotspots and cold spots of ecosystem service supply, but also supply use and demand mismatches. So of course, we think in terms of sustainability and quality of life. So we want that everybody who needs a certain service also can get a sufficient supply of this service. Of course, if you do the mapping and modeling of ecosystem services, both are quite closely related, then we have a very nice tool to produce maps and to give very relevant information for decision-making, nature restoration, conservation, or planning, of course. And then the part that Solen will talk more about, all this modern big data collection and analysis tools like artificial intelligence-based remote sensing data analysis, very good Earth observation products. We have open access nowadays available, so they're very useful for us in ecosystem service mapping, and they give very good information about the areas that we deal with and can be used for ecosystem service mapping and modeling, of course. I guess you also know this, the ecosystem service cascade. Just very quickly, we move from the environment to the social economic system. And then on the one side, we have the more domain of the natural sciences and related methods like measurements and modeling and remote sensing data. And on the other side of the cascade, we have more the domain of the social economic sciences and methods, value quantification, valuation, social cultural methods, economic methods. And of course, as I said, all these services are spatial phenomena. We can use the spatial assessment and mapping methods for all these parts of this ecosystem service cascade. Of course, in the end, these services are kind of the link between the humans and their environment, because this is what we look at, how they are supplied and how they are used by the society. So this is, again, these spatial methods are really relevant to quantify all sides of this ecosystem services delivery chain. With theory, I'm not sure how many of you have seen this, but when we talk about service supply, we look at service providing areas and service demanding areas. So where's the service supplied by nature and where the people or the groups of people or interest groups that demand the service. And then we have service benefiting areas, so there where the people can actually profit or benefit from the service, and we have some connection of these services. So in a very straightforward way, this takes place at the same area. So for instance, we have a lake that's very nice for recreation, then the service is consumed, as we say, in situ. Or you have a field with nice fruits, you go there, you eat them directly, no transport is needed. So the benefiting area is the same as a service providing area. Of course, we have more complicated cases where this moved in a certain direction. Like in this case here, we have, for instance, could imagine a green belt, a forest belt around an urban area, and then the local climate regulation and the fresh air moves directional into this direction where the service is demanded. And then you see already there's some area where there's service demand, but there would be an unmet demand. So if not sufficient fresh air is flowing from the providing area from the forest, then there's an unmet demand. And either these people remain without the service or they have to get it from somewhere else. Of course, this goes also in the other direction. Imagine, for instance, a habitat for pollinating species, pollinating bees or other animals, and they spread in all directions and then do in a certain area, they do the pollination of the plants that demand this pollination service. Of course, this can also go in a certain direction. If there's, for instance, a barrier here where the service can't move, and of course, also in the other direction where people that need the service, they then move here, for instance, to get the service. Like you go for recreation, you go to a certain place, you go to a place to get your food, you go to a place to have a swim or whatever. So then also you can move, and then you go to this service connecting areas. Of course, you also have services that can be transported, mainly provisioning services. Think about timber or food or water products. Then they have a transport from the provisioning area to providing area to the benefiting area. If there's no transport, again, you have an unmet demand. Of course, this can also be in the same area here, where the benefiting area is only part of this demanding area. So not everybody is profiting from the services. And again, there can also be a movement where people that demand a service move to receive the service somewhere else. So this is a lot of theory of ecosystem service mapping, but this is to show just a short introduction. You can, of course, read more about it if you want. Why mapping is also quite complicated. Because first we need to define where in the ecosystem, where in the landscape are the services supplied, where they're provided, where's the demand for the services, and where's actually the benefit taking place. And all kinds of flows of services on a global scale, on a regional scale takes place. So this makes it quite quite complicated to do all this mapping. I will, to make it a bit more clear, hopefully, show two examples. The one is about soil erosion regulation. This is a key project we have here in Hannover since 25 years now, actually, where we measure soil erosion by water. You see some pictures here. So these are fields here around Hanover and also in Baden-Württemberg and southwestern Germany, where very serious effects of soil erosion take place, and a lot of soil is moved by water and is then not available for instance, food production anymore. So what we talk about soil erosion, it's processes by water that we focus on, but also by wind, ice, or by gravity. And the aim of this service, so to say, is to avoid soil erosion and to have soil retention and also avoid what's called offsite effects. Some very basics about erosion. So you have some different processes. The water is coming, can move the soil material by splashing effects, or you have siltation where the whole material is moving downwards and you have the surface runoff. So one key effect is, of course, you have a reduction of the soils here on the slope. So the material is moving downwards and usually it's not coming back. So the farmer loses land for production. And the other thing beyond this on-site effects are these off-site effects. You have sedimentation on roads, in river or canals where the sediment material is not desired. So these are these on-site and off-site effects. And the aim is, if the soil erosion regulation is high, then these effects don't take place. So this is kind of the thinking of this service avoidance, so to say, avoidance of certain events that we don't want to have. So how do we quantify this? We do direct measurements since 25 years. So we go there and measure this with a yardstick, and then we have a GPS application where we can directly measure this. The idea is to calculate how much material is lost here and also where with a precise location. We use remote sensing, so drones is quite a good tool for us to track this, but also satellite pictures and air photos. We use also terrestrial laser scanning to check this erosion. Next approach would be the modeling. Universal soil loss equation is quite a key thing is here to calculate the potential of soil erosion, but also other guys like, these areas and invest maybe estimate that are able to calculate soil erosion. And nowadays we started to use artificial intelligence algorithms to especially analyze the big data that we collect there since so many years, but also data from remote sensing and try to identify which are the key parameters that actually control soil erosion in the end. So things like slope, location in the area, rainfall patterns, erosivity of the soils and soil structure. So these things we try to identify using AI-supported methods. So some results. So this is a map of potential soil loss in an area. So we are here, this is Germany. Hannover is about here. And this area is here in Niedersachsen, Lower Saxony, the federal state where we are located, somewhere here in the southeastern part. Quite heavy, loamy soils that are quite prone to soil erosion. And this is a result of the universal soil loss equation calculation. So you can see here, this is 250 meters. So this is maybe 2 kilometers, this one field here, field area. And then based on the soil loss equation, we could calculate where is a risk for soil erosion. So where is a demand for the service? So the demand for the service is only there where there's a risk for soil erosion. If there's no risk for soil erosion, like on a parking lot, for instance, you don't need soil erosion control because it's no risk there. But here you have risk in these areas, on slopey areas and a bit more hilly areas. There's a high risk for soil erosion. Then we compared this with the measured results, the actual soil loss that we were measuring since many, many years there. So you see here some forms where it really took place soil erosion, and this can be quite high. So this is then about 25 tons per hectare per year of soil that's lost. So that's quite relevant. It's more soil is lost than is regrown there, rebuilding there. So this is quite critical. And then if you compare these two maps, the one with the risk for soil erosion with the areas where the erosion actually takes place, then you can calculate a map of soil erosion capacity of soil erosion regulation supply. Because areas, as I said, where there's a risk for soil erosion does not take place, then the service supply is very high. If there's an area with a risk and erosion takes place, then the service is not sufficiently supplied. And this is what you see here in the map. And it's quite interesting results. And of course, then also will be given to farmers, to land users to adapt maybe their strategy of working on these fields. And what we do nowadays, this is quite new, that we use this neural networks, artificial intelligence based, to analyze our data and then try to calculate which are the important parameters that control soil erosion. And you see it's quite a similar result. It compares the modeled with the universal soil loss erosion and the mapped soil erosion rate based on this neural network. So this is what we do now with the big data that we have. So why is it so important? So soil erosion regulation takes place in landscapes, of course. And here you see this one landform that was also visible in the map. I go back, you see this one here. So this is an area where actually soil erosion took place 6 years ago. So quite good modeling. We were not happy that soil erosion takes place, but we were happy that our modeling results were so correct. So this is very tricky when you think about the service providing and demanding areas I talked about in the beginning, because soil erosion you cannot import. So this has to really take place at the place where you are. It doesn't help you to have soil erosion control somewhere in Asia if you need it here in Germany. So this is something that really is directly related to land management. So the areas of supply, flow, and demand have to be physically connected, because you cannot transport this service. That's why it's very interesting for us to work with this and concerning this ecosystem service mapping. And maps, again, are a quite important keyword. So for me, I'm a geographer, it's quite good. We think a lot in spatial contexts, but I don't know whether you knew that only 10% of human population are able to think spatially. This is what one chief statistician of the United Nations once told me, and 10% is not very much, but it's very relevant. If you ask people for a way how to get from A to B, they're usually not able to give you a very concrete map-based description. And this is also based on our perspective, why I put it here. So we usually have our very human-focused perspective. We look from one certain angle only and don't understand the whole system. This is why maps are very important. So here's here forest area near Hanover, and you see, and actually it's not the deer that's crossing the road, but the road is crossing the forest. So this is why maps are very good. They give you a look from above and give you a different perspective to understand all these processes and interrelations that take place in the landscape, also concerned to ecosystem services. So this was just a small side idea, but otherwise, perhaps you know them. They're very nice books about the power of maps and ecosystem service maps, where you can read more about it, and also what kind of mistakes you can make when you create a map. So I really believe in map as a powerful tool for communication, as a good base for decision making. This is the second part of my presentation about decision making. I guess most of you have heard about ecosystem accounting, the system of environmental economic accounting, where we are quite involved also in the development and application of this. So this is a global natural capital accounting approach, and it's consistent to the system of national accounting in the different United Nations member states. And the idea is to organize data in a policy-relevant environment around themes in a standardized way. And almost all United Nations member states have agreed to follow this standard. So this is quite nice also for us doing work on ecosystem condition and ecosystem services. There's a kind of standard now. And eventually these worlds of environmental economics and more social sciences and ecological sciences now finally come together in a standardized approach. And of course, it will also help us hopefully to deal with our environment in a more sustainable way, as the Secretary General of the UN said that we will no longer allow mindless environmental destruction to be considered as economic progress, because in the future, all UN member states have to report on ecosystems and ecosystem condition, ecosystem services. So they will not only report on the gross domestic product development, but also on ecosystem service and ecosystems development, which is quite a good progress, I think. Coming back to the spatial thing, so this is also quite a spatial approach. That's also why I can refer to what I presented in the beginning. So they are also talking about service providing areas, but they're called ecosystem assets here. And each asset contains a stock of a natural capital in a given ecosystem condition, and then results in a certain flow of ecosystem services from the assets to the user communities or economic units, so to say. So this is then accounting is recording this over an accounting period. And you see the maps are a bit more square than what we are usually doing, but in general, it's the same. You have different areas and they supply the services. And in the accounting, you first look at the extent. So where is which ecosystem type, each asset type. Then you assess the condition of this asset, and then you account first in biophysical terms, for instance, square meters or tons per year or something. And once you have this data, based on this, you base your economic assessment, usually based on exchange values. So this is quite good that you always have a biophysical database before you do this economic valuation. And then in the end, you have the account for this ecosystem asset. And again, it's quite similar to the cascade I showed in the beginning. So here's mainly the domain of natural sciences. And on the other hand, you have more the environmental economic methods that closely work together. Additionally, you have thematic accounts related to biodiversity, land, or water and carbon, for instance. And nowadays, of course, we have all this Earth observation and AI-supported data analysis available, and they can be used for many accounts. There are lots of projects also in cooperation with the European Space Agency to use satellite data for this accounting, because this is a huge task, as you can imagine, to have all these accounts quantified in a spatial manner. So remote sensing and big data analysis can really help us to have this also as time series. One short example only from our, now you see the animation, hopefully. We just started a new study project in the Harz Mountains near Hanover. You see this picture from last week we were there, how it looks like. So very serious bark beetle infestation. So all the spruce forests are more or less gone. And this is very nice. You can see this in the satellite image here from the Sentinel-2 from 2018 to 2024, how this is changing. So in the beginning, everything is very green like now. And then you can really see how the forest is decreasing. And this gives you quite quick and quite easily accessible information about forest extent, forest condition, and then, of course, also related ecosystem service suppliers. So these really are great tools that we can use in our mapping studies now. Another very prominent application of ecosystem service mapping are the biodiversity strategies of the European Union, 2020 and 2030. They defined as different targets. And for us, especially relevant was the second target, to maintain and restore ecosystem and their services. And within there, we had this Action 5, which asked all European Union member states to map and assess ecosystem and their services and integrate it into their reporting system. So this really boosted ecosystem services mapping in the European Union member states. Resulting of this was this working group of mapping and assessment of ecosystem services. They produced a lot of reports. You can download them for free from the website. So this is a very nice introduction also into mapping and assessment of ecosystem services. They're quite well written, very concise. So this is a very good science support also for decision making, and it finally resulted in the first EU-wide ecosystem assessment. The second one just started the works for, will be published in about 2 years. So this is very good application of ecosystem service mapping also. And then, of course, this led to the Biodiversity Strategy 2030. And there you find a lot about sustainable development and also ecosystem services, supply and use. And it's also very important that methods, criteria, and standards for these assessments have to be developed. So this, again, supports pretty much our work that we are doing here in our projects. And, of course, you might have heard about the new nature restoration regulation, which came into place last year, and it demands the areas, the member states, to restore 20% of the areas by 2030, and all ecosystems that need restoration are recovered by 2050. And of course, for these specific targets, you also need maps that you know where are the degraded ecosystems, where are the services, where's the biodiversity. And for these different types, of course, you also need maps to do this. So this is a nice backup in European Union member states, at least, where we need this spatial information. One last example I want to present is our EU Horizon project, SELINA. I saw quite some members of our project are also around here. Nice to see you. It's quite a big project with 50 partners from all 31 countries. It covers all European Union member states and also Norway, Switzerland, Israel, the United Kingdom, and also some selected overseas, outermost regions and overseas countries and territories of the European Union. So it's quite big, running for 5 years. We have half-time now. And also ESP itself is actually a member of this consortium, supporting us with the national chapters to spread our messages. We have 3 strands. One is about people, about stakeholders. The other one is a bit more science-based, about understanding ecosystem and the services. And the third one then is about applications, about decision-making support. So this is our idea to really support this transformative change that we are in urgent need. We produce a lot of databases, deliverables, reports. We create community of practice for networking in each EU member state. We have a lot of demonstration projects. We develop a lot of guidance and really have this as a kind of cycling structure to support decision making. So the key idea of SELINA is to transport scientific knowledge into direct applications and then learn from this application, improve our scientific outcomes, but really work very much on this science decision-making interface. For this, we have 15 demonstration projects, but they're real cases all over Europe, 7 from the public sector, public decision-making, 5 from the private sector in different countries on different scales, and 3 so-called hybrid cases in different countries. So the idea is to really test our outcomes there, present them ecosystem service maps and assessment results, and ask the people, is this useful for your work, or what do you need, how we can improve our work? One quite prominent example is the case of Coca-Cola. I guess all of you know this lemonade company, and they are involved in our project via Dengstat from Bulgaria. And they look where they can invest in the future in nature restoration, because they need a lot of water to produce their products. So they are very interested in water regulation, water provision, and they realize that this doesn't work in degraded environments. So they want to invest in nature restoration and create a business model for this. So what we support them with in SELINA is the methods development and ecosystem service quantification. So we are providing them ideas and kind of coaching and water-related models, how to calculate water availability in nature. Dengstat is then translating this, so to say, so that they understand what we are doing, hopefully. And the idea is that they have very good information about water supply and how they can put their investments best to keep this water supply also in the future. This is one idea where it's linked to ecosystem service modeling and mapping and practical decision-making. We have, as I said, 15 altogether, 15 of these demonstration cases. You can go to our project website and there you can see for most of them short videos introducing them, more to come, but you see all kinds of different cases. So this is our vision, to work together with decision makers, and then that our science contributions hopefully can do a change and contribute to the transformative change. But in reality, as probably most of you know, it's a bit more complicated working at this science policy or science decision-making interface. So we as scientists, most of us think very complex, and it's very hard to determine dynamics we have to do with very complex human environmental systems. And of course, also we want to have absolute certainty before we publish our results that this is very robust. On the other hand, we have the decision maker taking decisions that can be very relevant on the global scale also, or local scale. They don't have time to read or don't have ideas to read, so they want to reduce complexity. They want highly aggregated information and highly aggregated indicators. So in the best case, only one indicator, one value they can deal with, like GDP, for instance, has been in the past. That was very beloved, or is still quite beloved by decision makers. And of course, they want information and data that's relevant for their specific problem. And in the best case, it's supporting the policy program that they have. And they need it very quick. So this is quite a gap we have here, where we need a bridge to work together. Also from the science side, we have to adapt, but also decision makers have to adapt to read longer reports. And this is what we also call this urgency uncertainty dilemma of ecosystem service-based decision making, because some things are really urgent, like land use change, biodiversity loss, or climate change. They need quick decisions, not quick decisions, but they need robust decisions, and we cannot wait for 20 years more research to take the decisions. On the other hand, of course, it also has to be certain enough. The data have to be good enough. The maps have to be good enough to support our findings and to be robust enough to take good decisions on this. So this is something we really need to work on from both sides. So to conclude, I guess hopefully it became clear that ecosystem service supply and use are very complex processes, take place in space and over time, of course. We need this data and information and also the methods we need, for instance, for ecosystem accounting, for better land management, more sustainable land management and land use planning, but also for ecosystem restoration. This data and methods are increasingly available for use, so we should really build capacity to make use of these great data and methods that are there now. And the interest from policy and decision makers has really been growing in many parts of the world, not only in Europe, but other parts, that they realize that we cannot destroy our own base of our well-being and economic activities if we destroy our own nature. Yeah, thanks a lot for your attention. I really hope to see as many as possible of you at our session in Darwin, where we'll have more cases of applications of ecosystem service mapping from all over the world. And yeah, thanks a lot, and I'm happy to answer your questions if there are any.
Thank you so much, Dr. Benjamin, for your very insightful presentation. I would like to ask the participants to write their questions in the chat box so that we can have a question and answer session. We have few questions over here, so we'll start with Nitra Bhandari. One participant has asked to Dr. Benjamin that in the context of high resolution Earth observation data, how can we pick the appropriate spatial scale for mapping ecosystem services to ensure both ecological validity and applicability for policy and planning decisions?
Yeah, thanks a lot. This is, of course, one of the key questions when dealing with spatial assessments and mapping. What's the best scale? So what we try to produce since many years, actually, in this thematic working group of the ESP about mapping ecosystem services, and what we also continue in the SELINA project now to develop some guidance. So we have a kind of checklist for each ecosystem service and ecosystem type to say, okay, this service is best being quantified and assessed on this spatial scale. As I said, if you deal with water regulation services, you should usually look at the watershed scale. If you deal with urban ecosystem services like urban greening, of course, green urban areas, of course, you should look at the urban scale. So this is something really try to work on guidance, which is not so easy because it's very complex. And then, of course, if you do an assessment, as you mentioned already, you have to, in the question, you have to look what is the scale of your problem. So you don't need a global map of ecosystem service if you want to change local climate regulation in your local area. Then you might not need it. So then you look at the local scale. So it really depends pretty much on the service. What is the best spatial scale? And then on the question you want to address. Like many things that are produced in this EU ecosystem assessment that I presented, they are all maps on the European Union scale. So they're very nice. They give a very good overview of what's going on in Europe. They're quite good for European Union-based decision-making, but they will not help you on the local scale. So you have maps of soil erosion regulation on the European Union scale, which show interesting patterns, but you can't go with this to your local field and say, okay, this is now for your land management very relevant. So this is really a combination of the service, type of service you deal with, but also the question that you want to address.
I would continue with the second question. If Netra has a following question, we can ask Netra to unmute herself to ask the following question.
No, thank you.
Okay. So, Dr. Benjamin, the next question is like, as you mentioned about the soil erosion mapping, the study you mentioned. So, the Nita is asking where we see the the Malika is asking where we stand on the implementation part of that kind of ecosystem services researches, as in if the study you have done, how the results are benefiting the farmers or the local stakeholders at that place.
Mm-hmm. So in this project, we work very closely with the farmers. They know us, we know them, they get our reports. And they get direct information on their fields where there was more soil erosion and where there was less, and then they can adapt their management. They do adapt their management. So, for instance, you don't grow potatoes on very steep slopes. You don't grow in certain periods of time. You don't do plowing on certain soil types where you better do plowless agriculture. So this is information they receive directly, which is good. They improve their management, but it's a bit tricky for our research because then it's not, it's changing. If they change their management, also our results change. So we have less soil erosion, which is good, but it's not an independent study, so to say, anymore. So, but in the end, this information is very important and they use it. But for our study setting, it's maybe not the most optimal because it's not independent anymore. But of course, we have the mission to avoid soil erosion to support the services. So that's why they get the results and use them. And indeed, you can see that in the areas where we give the recommendation, soil erosion actually gets less. So this works quite well. And this is also why I like this example very much, because it's very concrete from the measurement to the analysis to the modeling and then to the farmer. And then you have the next cycle and you can see, okay, does it help? Does it work? But it also gets more complicated nowadays with the changing rain patterns. The climate change we see already, you have areas. Now I think there was 5 millimeters of rain in the last 2 months here in our area. And last year it was 10 times as much. So it really changes a lot. These rain patterns, which of course also has an effect on water-based soil erosion. So this makes the things even more complicated now to predict.
Okay, so due to availability of time, we will take one more question. I'm seeing few questions regarding the AI and the modeling related with the ecosystem services. So I'll ask one on behalf of all the researchers that, as you mentioned, to use the AI in analyzing the large data sets for the ecosystem services. So how can the early career researcher can gain the skills of these new technologies, and what are the new open sources tools you can suggest so that they can work on the AI thing with the ecosystem services?
Yeah. So the key idea of AI is, of course, that you detect patterns and things. You can identify things you don't see with usual techniques. Of course, many things you can do with geostatistics in the GIS already. You can do correlation analysis. But the idea of AI is to look a little bit beyond. So they check, they learn from the data that you feed, that you train them on, and then they might detect correlations or parameters or variables that you haven't thought about that they're very important. And the nice thing, they can do this also in a spatial way. So we all have in our AI models, we have a spatial component. And then the model is just calculating, doing data combinations, parameter combinations, and detect really new patterns that you as a human would not detect, but also your common geostatistical tools would not detect. So this is the idea. But of course, it's relevant on your data set, what you have. It's important to check. It's important on your training data. Avoid overfitting, all these kind of things that are there. But it can really help to look beyond the usual patterns that you usually would detect. And as I said, we use it here in soil erosion, for instance, to detect the key variables that are driving soil erosion, that are important there. And in time series, in a spatial way. So this is really a new technique that was not available so long ago, that we use a lot here. And thinking about open access, I guess the most common tool that we are working with a lot also is R. So in RStudio, you can quite easily program your codes. It also has a GIS component, of course, where you can work in a spatial manner, and this is quite nice. And you find a lot of codes already on the internet. You can also use large language models like ChatGPT to improve your codes or to even write them for you partly. So this is something we can really use. So I can recommend you to work with R or comparable softwares, of course. But I know also that, like for ArcGIS, they're also developing things like this more and more. That also in ArcGIS, I guess soon you will find even more AI-based approaches. Like we work a lot with random forest for simple application, or then you have this deep learning tools like this evolutional neural networks I presented for more complicated data sets. But I think this has a huge potential for us in combination with Earth observation data to do better ecosystem service assessment and mapping and modeling.
Thank you, Dr. Benjamin. We have few more questions regarding uncertainty of the models and how we can relate social and natural sciences together, and regarding policy research. But due to time constraint, I'll ask Dr. Burkhard to answer some of the questions if he can in the chat box, and we'll move forward with the webinar. And if we have time left, we can come back to the questions again. So, okay, so going further, big thank you again to our speaker, Dr. Benjamin. And the next part of the webinar will be facilitated by Johan. So the floor will be yours, Johan.
Thank you, Raul and Benjamin, for such a great presentation as well. And I would like to welcome Professor Solen Here, she's part of the Wageningen University in the Netherlands, part of the Earth Systems and Global Change Group. Her expertise is in spatial and temporal dynamics of the socio-ecological systems, with a focus on the landscape, ecosystem services, and the public policy interactions, which is necessary, especially nowadays. And she's also part of the ESP Interim Executive Committee. So thank you once again for accepting our invitation, and the floor is yours.
Thank you so much. So let me share my screen, see if it still works. Okay. Does it work?
Absolutely. It works.
Yes, all good, all good.
Great. Okay, so good afternoon, everyone. Thank you so much also from my side for being here. Thank you, Benjamin, for this super nice first part of the webinar. And thank you, Jean and Ruhar and Kien for inviting us. So it's a real pleasure to be here. And I'm going to build upon Benjamin's presentation and go a bit deeper into what are the new technologies that we can use or that are now being increasingly used to map ecosystem services. So some of them, most of them, they use in all general assessments. And I'm focusing here really on the mapping. And what I would like you to get from my presentations are that there are a wide range of new technological developments that support the assessment of ecosystem services and the spatially explicit assessment of ecosystem services in particular. So all these new technological developments, they really have a huge potential to overcome all the still current, let's say, knowledge gaps and limitations that we have while assessing services, and in particular in data availability, but also data processing and data visualization and communication. There are still some constraints because each of those approaches have very strong advantages that I'm gonna show partly, of course. I have limited time, I'm not gonna show everything. And they also have still limitations. So there is still a lot of work for us to do as a mapping community or ecosystem services community. And what is really also one of the points that is increasingly being acknowledged and that also require a lot of future research is the complementarity of those technologies. So they are increasingly being used in combination, but only some of them. And there's much more to explore to increase our ability to map more services at a better spatial temporal resolution, and then improve, hopefully, the uptake by decision makers. So what I'm talking about here in this presentation are mainly the digital technologies that we use in order to map ecosystem services. So there are all these digital supports to assess ecosystem services that are related to the data, to the devices, and to the method. And all of them, they can be used either to collect and store, process, and visualize data on ecosystem services and visualize them in a spatially explicit way. And I'm going to walk you through a couple of these methods, these technologies. First, quite logically, the one related mainly to data collection, then data processing, and then the one that are more related to the visualization, outreach, and engagement. Of course, there are overlaps between them, but it's just one way to classify them as it was made in a very recent review paper. Before I do that, I would like to stress the reason why we think those technologies are critical. So they do really have a potential to change the way we map ecosystem services, and by doing that, the way we understand and we manage the natural resources, simply because they lower the cost related to ecosystem services assessment, they increase data availability. They may also improve applicability of tools across different users, across different places around the world. And also, especially the one related to outreach, communication, visualization, they really can create new opportunities for learning and to communicate the dependency we have towards natural resources, but also the state of degradation and the options to improve the management of them by combining those technology with scenario, for example. So they can improve the assessment, the mapping of the services themselves, but they can also help with the monitoring. So maybe like a time series of ecosystem services mapping. So you seeing the trends over time, the spatial temporal trend over time. So let me start with the first technology that is related mainly, but not solely, to data collection. And that's Earth observation techniques. So of course, Earth observation in mapping ecosystem services and natural resources is not new overall. But what's new is that we're really into the golden era of Earth observation. Of 2021, we had almost 3,000 operational satellites orbiting Earth, and more promising satellites upcoming to monitor the state of our resources. We also have more diversity of Earth observation techniques used, well, in general, but also used in ecosystem services mapping. So we have satellites, of course, but we also have airplanes and the uncrewed aerial vehicles, in situ instruments like the LIDAR devices, for example. We also have more and more of these CubeSats satellites. So those are the ones that are very light and allows for, at very low cost, the monitoring and the mapping of our resources. So we have more and more data that we use in order to map ecosystem services. So Earth observation data or images, they are typically used by deriving some data on ecosystem properties that are then used as proxies or directly used to map ecosystem services. So that would be, for example, the NDVI, one of these very common vegetation index, for example, or land use land cover classes that are derived from satellite images and that are used as a proxy for multiple or single ecosystem services. So those Earth observation data, they are still mainly used for regulating and provisioning services, a bit, of course, with cultural services, but there is still a lot of work to be done in that respect. And why are they used so much? Well, because they can cover more or less the entire world, depend on the satellite, and they provide continuous information over multiple spatial and temporal scale. And by doing that, they allow us not only to look at a snapshot of the state of the natural resources, but also monitor through time series the state of these natural resources and ecosystem services. So we can also map ecosystem services over time in a rather cost-effective way. So far in ecosystem services mapping, Earth observation has been mainly used through passive satellite sensors, and that's, for example, Landsat or some of the MODIS images. But more and more, we use also active sensors. So the one that have their own source of electromagnetic emissions. And those would be the Sentinel-1 sensor, for example, or LiDAR. Similarly, mapping ecosystem services has mainly been done through high and middle spatial resolution sensor. So that's from 10 meters to 1 kilometer. But more and more we can see there are more and more very high resolution sensors that are being used. That means sensors with spatial resolution are below or above, actually. So it's finer resolution than 10 meter, right? So you can have much more accurate assessment in the air. However, especially those high resolution, so high spatial and or high temporal resolution, they can be very expensive to process and, well, first to obtain, right, and to process. And they also require quite high computer power and processes time. Another maybe challenge or rather limitation, actually, is that ecosystem services mapping has mainly been done using Earth observation at local, regional scale with very little attention drawn to global studies so far. And another maybe limitations, and you will see that actually in all these technologies, are validation and calibration. So this is still a main source of uncertainty, and I saw in the chat there were quite some questions about it, and I will go back about that at the end of this presentation. And validation and calibration can be particularly challenging at global or large scale, but also, and that's kind of related, in highly heterogeneous areas. Another new data collection digital technology are related to the mobile technology, the use of social media, and crowdsourcing. So those technologies, they are still mainly used to assess and map cultural ecosystem services, and in particular, recreation and tourism. So there is still a lot to be done in order to better capture the spatial distribution of other sort of services.
I saw it, Solen, you're mute.
Does it work now?
Yes, all good now.
Okay, I don't know what happened, but let me share again the slides. Okay, I think it works again, doesn't it?
Yes, it's working now.
Yes.
Okay, perfect. So I don't know when I was cut. But I was telling that the mobile technologies, social media, and crowdsourcing are increasingly being used to map ecosystem services, but mainly the cultural services. And they are mainly, well, they are increasingly being used because we have more and more, mobile phones, different GPS sensor, also more and more well spread, but also all these Web 2.0 technologies. And that means all these social web and participatory technologies that really stress the user-generated content. So those techniques, digital techniques, can be seen as a form of reveal preference data to understand, that also help us to understand the activities in nature. So why would people take a photo of that, for example? And that's also why it's easily linked to cultural services, and in particular, recreation and tourism. And the good thing is, because it's increasingly being used, it also generates more and more data. So it can, in turn, be even more increasingly be used. And we can also get some and more time series, for example, maybe on some specific areas. And because those technologies, some of them like smartphone, are globally spread, and they are now very simple application in order to use those sources in order to map services, or to get the data that we can use then into maps. That means we can reach quite wide audiences, and we can also get a very good coverage, spatial coverage of a lot of different areas around the world, even though that in which it might be difficult to do some other type of field work, for example. Then I move into the technologies that are more related to data process. And of course, as I said, there are some overlaps with between the categories, but they also kind of really, they can be used also as data collection. Like, let's put it that way. So one of the technology is related to data science. So data science really allows us to turn large and complex data sets into actionable knowledge. And this for us can really be critical to really understand the dependency we have to ecosystem and the challenges of global changes. So how the ecosystem services provision changes over time and across space. So this data science, it encompasses or it entails a lot of different techniques, and they are usually characterized as being advanced approaches that are usually a combination of computer science and statistics. And they are used, and that's why I say they overlap, for the collection of data, but also for the computation and the analysis of a lot of sometimes heterogeneous sort of data. Data science can be used for any kind of services, but it seems to have been mainly used for cultural services, at least some type of data science. They can be used to monitor trends and temporal dynamics because if for some sort of data science, we can collect data over a long period of time that allow us to monitor those trends and those dynamics. And because data science is per definition data-driven approaches, it really helps us not only to visualize, to map things as a visualized tool, but also to understand patterns beyond understanding the pattern, the spatial pattern, by looking at the map itself. One type of data science is related to machine learning, and which is also part of AI generative sort of ecosystem services map. Machine learning, but also big data, can really help address issues related to data availability, especially in understudied area. So what is machine learning? As I said, it's linked to AI because it's a branch of AI that focuses on the development and the application of algorithms that can learn and make predictions from data. Because it can use data from the social and from the ecological spheres, it really can help, and it has been helping now in the assessment of ecosystem services and connected those two different aspects from the cascade that are still quite disconnected, despite our efforts in the last decades. One of the big strengths of machine learning is also its ability to estimate, to some extent, uncertainty through their algorithm itself. And also because it relies on big data, it can maybe decrease uncertainties because of the size of the sampling, so to speak. But even that, even besides that, challenges still remain related to the accuracy of the results that we get from machine learning. Another technologies related to the data process in ecosystem services is about modeling. And you will tell me modeling is not new in mapping ecosystem services, and you would be absolutely true. So modeling is something we've done for ages, spatial modeling in this case. And it's been done for ages for a good reason, because it helps really us understanding cause-effects relationships, or at least it's built on relationship that we need to understand in the first place. It also allows to potentially monitor trends and temporal dynamics, but it also can be combined with scenario in order to reveal, for example, trade-off between different management options. So it really helps us understanding the socio-ecological systems, but its past dynamics, but also how it could evolve in a potential future. In some cases, it allows for validation, robustness check, and also give you information about uncertainties, but it really depends on the modeling tool that you use. It usually can be applied in different places in the world, sometimes at different scales, so it allows for upscaling and outscaling, although here again, there is a big avenue for future research. And it can be combined with participatory approaches in order to get, for example, validation data set, or to get some more input as a parameter inside of the model. So as I say, modeling is not new, but in the last years, two main trends maybe emerge in terms of modeling. One is the integrated models or integrated tools, like to some extent INVEST or NatCap, but maybe more interestingly, MIMES, or I don't know how it's supposed to be pronounced, but the multi-scale integrated model of ecosystem services. And by an integrated model is very important because it can really give us a deeper understanding on the socio-ecological system and really improve the accuracy of the ecosystem services map. And integration can mean many things. It can relate to scientific disciplines, so you try to have economics, ecology, integrated in the model. It can be about integrating different perspectives, so trying to understand how people perceive or value certain ecosystem services, or who influence, who are affected by decisions. It can also be about the different components that are being looked at in the environment or the interactions, so looking at system. And it's also about assessing at different spatial scale or temporal scale or resolutions. For example, local, regional, national, up to global scale, for example. The other trend in modeling that is rather new in ecosystem services mapping is the use of Bayesian neural networks. So it's being increasingly used. And this is a type of neural network that incorporates probability distributions over its weights rather than fixed value that you might have in more traditional modeling. And one of the strengths of Bayesian neural network is that it allows the model to estimate uncertainties in prediction or in the values that then can be put on the map. So how it works, I'm not going to go into detail, but you have causal networks that link parent and child nodes. So suppose that you're mapping, let's say, urban cooling service using this kind of modeling. Your parent nodes might be the input data, such as urban density or the vegetation types, cover, and extent, and the probabilistic weight. And then the child nodes are the predicted, so your output cooling effect at each of the locations that you're studying. And that really depends on the input data and the weight distribution that you put in the model. It's quite logical. The probabilities or the weight that you put in the model, they can be based on expert knowledge or on literature. One of the drawbacks, it really requires very high knowledge of ecological threshold, for example, or about the relation between the different variables. But again, one of the strengths is that it addresses uncertainties in a much more explicit way than most of the other technologies that we have. Now going to the technologies that are more related to communication and outreach and cross-learning, or about also making people learn from making the map and using the map. So those are, for example, the immersive reality and virtual reality. So that's one of those immersive reality. So what are they? It's about reproducing some characteristic of an ecosystem of a landscape, and that would be the visual characteristics, maybe also the sound characteristics. And it really facilitates the evaluation of people's perception in a very controlled setup, in a way, right? So it's increasingly be used, but I don't think it's being used. There is still very little literature on that, right? But it's a lot about cultural services so far. And it helps really experiencing the nature, and it can be made through the visualization of the map, but it can also enhance the quality of the map, for example, because people participating to, let's say, the experiment can be asked questions about their experience, about the ecosystem services, their perception, their awareness, this kind of thing, which in turn will improve our knowledge and may improve the map or the environment that they were confronted to. Of course, sounds very great, but there are limitations and very strong technical limitations in the collection and the presentation of, for example, how we react, but also related to the video camera that we need, that should be very high tech, for example. Also, it's very limited, very locally and time limited in a way. So we need much more development in that respect to have, for example, time series. And then we have participatory mapping and role play. So those are not necessarily digital tools, but more and more you can see that they're being supported by digital tools. So those activities or techniques, let's say, they are really useful in order to co-create knowledge, but also to raise awareness. And they're increasingly be used in transdisciplinary learning, but also in decision-making process, for example. So you have the traditional role-playing, as you can see on the top image, but you can also see like a digital version of it, which is not, I think if I remember correctly, not specific ecosystem services mapping, but it was more for the illustration purpose. And the information, the knowledge that is created during those sessions of games, those game sessions, can really be used afterwards in decision-making spheres. One of the issues is that, well, I guess there are too many issues. The first one is how to get people on board that are, so how to play the role of the shadow actors, for example, in some of the area around the world. So that makes the thing very difficult. The other is that the role play, the games in general, they are very tailored for very local situation and very hard to make it more generalized and more applicable to other places or larger areas. Finally, we have the GIS that are more participatory or volunteer-based sort of information. So the participatory one is really a spatially explicit method in which you capture spatial information that involve different types of stakeholders. And it uses random sampling method or purposive sampling methods that can use digital or non-digital mapping technology, right? And that can be done through interviews and workshops, surveys, these kind of tools. And then you have the volunteered geographic information, where people voluntarily add some information on an existing GIS, for example. And that's about reporting in the geo-referenced way, location, points of interest, which again gives us a lot of information and can lead to making maps. We can directly create maps through a direct visual interface. And it's a lot about cultural services, but it doesn't have to be cultural services. So all those tools are very promising, but there are still a lot of challenges, but there are also a lot of opportunity, or maybe, I don't know if they are really low-hanging fruit, but easy way of thinking that we could improve. One of the challenges that there are no standardized methods. So we have a lot of tools, we have a lot of data, but we still lack standardized guidelines and way to collect the data, the way to process it, the way to present it to decision maker. So we now have to navigate a more and more denser and denser jungle of data and models. So that's in a way make it much more difficult. So having guidelines and practices for reporting how we use the technology, how we should not use, would be very helpful. For example, open science in that respect can really offer a lot of opportunity by sharing codes and good products and algorithms. Other challenges will be related to the size of the data, because we have more data, and how do we store it? How do we process it? And how do we make sure that it doesn't increase the gaps between the people or the places when you can't afford the technology to process so many data? And the same with the accessibility of data and the technology in themselves, right? So how to ensure more equal access to data and increasingly difficult equal access to data. So that would be really something to think of, continue to think of in the future. Another challenge is linked to the validation of variables, models, and technologies that are used. So for example, the machine learning, they look very promising, they're more and more popular, but they're often black box tools. So how to deal with that? And that can be through a better assessment, communication of uncertainties. Is it sufficient? I don't know. And it's maybe also about having model ensembles where you capture better the complexity of socio-ecological systems. Most of the applications are still at the local and regional scales at a certain time, a snapshot of the time. So we still need to better work on spatial scales and spatial and temporal scales. Yeah, like that would be fun to do, but that would be also super relevant to better manage our resources. But also with all those technology, we need more and more expertise on programming, on participatory approaches skill, and this kind of thing, especially if you combine those technologies. So we do need more and more collaboration between researchers and stakeholders, especially in this very chaotic world that we have nowadays. And the last one is not a challenge, but really a point that I wanted to make as a way forward is that there is a really high potential to integrate those technologies for deeper insights. And that would be combining those technologies, those new technologies together, but also combining them better with the traditional approaches that we already have, and creating, for example, more ensembles of ecosystem services models to map them, to better combine passive Earth observation, active Earth observation with social media data, for example. But I'm also aware that it's going to be difficult because of the high complexity of doing that, of the costs involved also for doing this kind of things. One thing that I have at heart very much when mapping ecosystem services is the uncertainties and how we should consider it in order to enhance uptaking in decision making. So how to enhance the uptakes of our maps in decision making? It can be by clarifying the policy context. So what is the context in which the map will come? What are the needs? What are the wishes from the decision makers? It's also about making sure that the stakeholders are involved and that their wishes are heard and ideally incorporating in the mapping process and in the mapping results. But it's a lot about assessing uncertainties, and in particular by the uncertainties at different level. So that would be the one linguistic related to the decision making, for example, but also the uncertainties related to the modeling itself, so the mapping process itself, and the one related to the scenario when maps are used in order to capture a different time frame of the state of our ecosystem services. And scenario analysis may help navigate uncertainties, but it needs to be done explicitly, and we're still lacking the way to do it. Yeah, so I don't know how I'm probably over time, so I'm gonna stop here for this part on the technological advancement, and I'm just gonna take a few minutes of your time in order to present you the working group. So from the survey, there was at the beginning, half of you are familiar with the ESP or part of the ESP. That means half of you is not. So let me just tell you that the ESP and the ESP conference is really a special thing. It's like a family in a way, and going to the conference, going to a family reunion, but also meeting new people with great ideas. So it's fantastic, and it's always a pleasure, and I hope you will experience it if you haven't experienced it yet. And it's actually funny because that's where Benjamin and we first met back in 2014, I think. And I think we met more or less every year at this ESP conference ever since. And it's really a nice way to get inspired, to get updated, and also to have a lot of fun, right? And the ESP is organized in different working groups. There are some that are related to some biomes, some are related to some themes. And one of the thematic working group is the mapping working group. And that's where Benjamin and I are involved, or one of them where we are involved. So the Mapping Ecosystem Services group is a group that meant to bring together experts that are, well, mapping ecosystem services or interested in learning more about it. So, I mean, Benjamin presented super well the role of the map, how to map it. So I'm not gonna repeat it, but yeah, maps are critical. They're important in science because they help us understanding better how we depend on the ecosystem, basically on nature, by putting the where question on the map. That's a bit unfortunate wording. But it's also help with the societal sphere and the policy making sphere, because they can help with raising awareness, communicating, but also helping with decision making or having a debate in the policy sphere, for example. But they do require a lot of effort, a lot of expertise, and a lot of intern transdisciplinary effort. So the more we are in this working group, in a way, the merrier, because we can really help. We can really, learn from one another. So mapping, I think that's pretty clear, right? Rely on a lot of data, a lot of technology that require expertise. And what we aim in this context is really in this working group to advance research and implementation of ecosystem services by developing tools, guidelines, and standards for improving the spatial analysis. So again, putting the where on the map. And what we want is, so how can we get better ecosystem services mapping to lead to better uptake of ecosystem service in the society, in policy sphere? How can we provide such better map? And also it's all a reflection on our map, what is really needed? Are they appropriate for certain groups of stakeholders or for all of them, and for whom? And what does it mean? And because maps can be most of the times means and not ends, how can we use the outcomes on the map for further analysis, for example, linking to environmental justice? So in this context, we have this mapping group that tries to answer those questions. And what we do in terms of activity, so we meet, or we organized every ESP conference a session that sometimes it's a whole day session or a whole afternoon session. So we have very exciting talks from people from all over the world, different kind of background. It's super interesting. And we had a couple of joint papers that are usually a result of those conference sessions. Those are our main activities, but of course, if you want to be involved and have other ideas, we're more than curious to hear them and taking into consideration. And our next activity will be at the Darwin ESP conference in June, and we're going to be looking at the latest advancements in ecosystem services mapping using cutting-edge data, method, and tools, looking at what improvement happened in spatially explicit assessment, looking, for example, Earth observation or the big data analysis. What are the advancements in terms of monitoring? Did we improve there, and how? And related to large-scale data science and big data and AI related mapping. So the idea is really to get a better understanding of what the state of the art is in terms of those new advancements in ecosystem services mapping, getting this update from the entire mapping community on the applicability. So what has been done? What are the successes? What maybe were the limitations? How can we learn from one another? And I really hope to see you there, or if I'm not even joining myself, to get a full report from Benjamin after the session. Thank you so much.
Thank you so much, Solen, for the presentation and for introducing ESP and the session. I hope many of you can attend, because it's really a community space where we can all get to know each other and also promote networking, which is really important in our areas. So again, thanks for the presentation. I think we understand the importance to be updated in the new technologies and in this rapid transformative world. Also interesting to see the virtual reality. It's something that I also heard about it for a long time, since I was a student, since in 2016. But I think, this is my opinion, this is very not so implemented in science, but more in applications in other industry, for example, but not such in science. So maybe we can think about this as well. Also interesting to see how data science is more related with some specific ecosystems, the cultural ecosystems. And also, I think it's important what you said about the NIMES and the Bayesian neural networks. So they are kind of the new trend. So this is good for us to explore if we can implement in our project. So once again, thank you. And this was my comments. We will now open the comments and Q&A session. So we will do this like in the previously presentation. If participants want to ask directly to the speakers, and we will open now again first to Solen and then to Benjamin for the last question. But first, please, I would like to prioritize the presentation. So you can just raise the hand and you can talk or write in the chat if anyone has some question considering the presentation. I don't see any question now. No. So I can start to ask myself a question. I also have some questions. Let me see which one it could be more interesting. Okay, about the VGI, voluntary geographic information. How scientifically is correct to use VGI to access ecosystem service? It's an approach of some kind of validation. It's complementary to the information that we already have. How it is scientifically speaking, the introduction of VGI, maybe not so much related with stakeholders, because we know that stakeholders is also a hot topic now, but specifically VGI in terms of accessing ecosystem services.
I think that's a question that everybody could try to answer. I don't pretend having the answer. So just VGI for everyone. This is volunteer geographical information. So those are the, let's say, GIS, where people on a voluntary basis fill their data on the perception. I mean, it's a perception sort of tool, right? So I think this is very valid, but it has to be taken as it's a perception, right? But again, I don't know how it can be validated. So that raised the whole question of validation. And I guess that can be done in, those would be typically one of the tools that would be very interesting to complement with another one.
Interesting, a complementary tool with another assessment.
Yeah, good. But then again, because it's about perception, you know, it's super important that it's valid as a perception in itself. And it's something we really need, especially people who are trained to think of, you know, hardcore natural sciences, and it is valuable, input data.
Yeah, thank you. Yeah, for sure it is, and maybe we should start to think also to use more of that in our assessments, because it's also a question, validation. But
it could actually be used as validation as well, right?
Yeah, complementary validation, it's a good approach then. Yeah. And do you think the modeling revolution, it's already here with these new advancements, or do you expect soon, because every year we get new technologies, new information, or there is something we can expect perhaps in the next years, or there is already the new technology is already here? We don't need, or the revolution is already here in terms of modeling.
I don't know about the technology itself. I think we have a lot of things already, but there are a lot of improvement. And I'm not saying they're easy and they will be next year available, but there are some easy, let's say, improvement that can be done in the existing models. And for example, capturing cross-scale interactions, it's not there. We don't know how to do it yet, or it's very, I don't know any models that does that, or the feedback loops within ecosystems, right? Between ecosystem services, for example. So for example, if you put hedgerows by a field, then you assume that you have less yield because you have less space for your yield, but actually you will have more natural pest control, maybe more pollination, these kind of things. But this positive feedback loop, they are not captured in the model yet. in most of the models. So this is also not an easy, but a possible improvement in the future. In the future, and also the integration of different perspectives. Like you say with the volunteer geographic information system, right? So having these different values, perception, but also value of nature within the model, that would be super great. But we're not there yet. Yeah, and also the uncertainties, like validation of model is not systematic yet. How to capture the uncertainties and how to capture them in a way that we can then, present them, communicate them to, let's say, decision makers. This is also something that needs to be improved in the model and in the post process.
Completely. This is always a very big issue, uncertainty. And also the feedback loops, very interesting. We can expect maybe that implementation on the models. I will keep that as well, the feedback loops. We also have a new question now in the chat from Melanie, which is also thank you for your presentations. So it's again related with uncertainties. While as a scientist, I'm all for communicating uncertainties. We previously talked about how decision makers need simple and clear results from science. Okay. Therefore, how do you propose to go about assessing and communicating uncertainties to have an impact on policy makers and also on stakeholders? We just talked a bit about that now. I don't know if you want to comment, Solen.
Yeah, it's a tough question. Huh? I don't have a good answer. So I think, no, I really don't have a good answer, but I think it's really about being honest about how certain we are in the model in general, but also if there are some areas that we know that the model is more uncertain, that's good to communicate. In terms of scenario, showing how different scenario would yield to different maps or to different management option, if the scenario not already management option related. That would be also one way to go, I think. And I guess also communicating from the beginning with the decision maker and walking them through the entire process. If it's possible, maybe I'm too much of a dreamer, but that could also make them a bit more aware of how the maps are produced and how in all of those steps there is uncertainty that builds up in a way, and they could be more critical about it, because what we also don't want is that they are too critical and they don't trust the map anymore, right?
Completely. And then also be clear then about the limitations of our models. Our models are wrong, but some are useful.
Yeah, they're all wrong. They're all wrong.
They're all wrong, yeah.
That's the thing. We also need to be not defensive, really, but defending our maps in a way. If we create it and we are confident that they have a potential, we also shouldn't just point out the limitations. So it's kind of a tricky balance, right? We want to be transparent, but we still want to build the trust by showing uncertainties, but also not by destroying our own work. Otherwise, the policymaker will not use our maps anymore, which is not what we want either.
Exactly. Yes, otherwise no information available. For talking about defending our maps, Benjamin, do you want to add something on this related?
Defending our maps sounds very serious, but I think this uncertainty topic has been around since many years now. It's very important. But I mentioned already in the chat, I mean, if you look at IPCC reports, they do this since quite long. Very simple measure. They say, okay, this has high certainty, medium certainty, low certainty. I mean, you can also talk about certainty to put it maybe a bit more positive and not uncertainty. But with this, I think it's very important because some things are quite clear. They can say, okay, this will definitely happen, and other things are less certain. And then you can anyway communicate them to raise awareness, maybe to trigger also further research and further thinking. But you don't need to hide the results, but you still can be honest, as Solen said, and say, okay, this may be tricky, we are not so sure about it, but still you can communicate it. But otherwise you just do research and you'll never be able to publish it or to give it to the audience to make it useful. Because as you said, nothing is really 100% sure, but some things are more sure than others. And if you communicate this, I think this is very, very important. Yeah.
Thank you so much.
And maybe
Solen?
to add, maybe that could be a nice topic of a webinar. I mean, I just had a lecture of uncertainty in ecosystem service assessment with my students, and it was 2 hours lecture. So that could be a nice topic also for a session at one of the next ESP conference.
I think we get some motivation at least out of the webinar. Great outcome. Yes, and it's an eternal question, right? And at least until now, as Benjamin said, we always see this for many, many years. So, and many more years will continue to listen this, I think. So, any other question? I think not. So it's time to close the webinar. Once again, thank you so much for the participants to be attentive with us on this great session. Once again, thank you so much for the great speakers we had today. We are very proud that you join us in the session. And Raul, if you want to say some last words, and the floor is yours. And danke schön, and thank you. Obrigado.
All right. Okay, so that brings us to the end of our engaging discussion on ecosystem services mapping. And I would say that was a very insightful Q&A session, and I'm very thankful for Benjamin and Dr. Solen. So they have answered all the questions, and especially Benjamin has written all the answers in the chat box, which is amazing. Yeah. Thank you once again to our speakers, Dr. Benjamin and Dr. Solen, for sharing their expertise and valuable insights. So this webinar is a part of a broader effort by early career researchers to foster collaboration and growth within the field of ecosystem services. So therefore, before we officially close, I'd like to draw your attention to the session number 03, which is on grant proposal, research writing, and networking toolbox for ecosystem service researchers, hosted by ES Network at the ESP World Conference in Darwin coming June. So I would like to just give a small information that although the abstract submission deadline has passed, if the participants or anyone, if anyone is still interested in presenting at this session, we will like to invite you to contact the host and co-host regarding the submission, and we encourage everyone, especially early career researchers, to explore the ES network further so that you can find more information. The link is provided there. You can have more information on the website. And so therefore, thank you for all your active participation. We hope the session has been beneficial. We appreciate your time and engagement, and we look forward to connecting with you in future ES network activities and events, and also in ESP World Conference in June. Thank you. Have a wonderful day. Thank you so much, everyone.
Bye.
Bye-bye.
Bye-bye. Thank you. See you in Darwin.